thing has turned red, so I think that's a good sign. So anyway, good morning. Still morning. My name is Richard Gilbert, and I'm a front-end engineer with Civic Actions, and I'm here to talk about one of my favorite front-end concepts, viewport units. It's funny because I named this session Fun with Viewport Units, and then after it was accepted and everything, I kind of stumbled on a pretty great post by a woman named Miriam Suzanne on CSS Tricks, which is called Fun with Viewport Units. And I hadn't seen that before, so I guess it just goes to show you that viewport units really are a lot of fun. So you can find, you can actually find this whole presentation at bixgomez.com. As maybe some of you know, I think Mike might know, Bix Gomez is an alias I've been using for a very long time. It dates back to the 80s, and it's a long story, but I've kind of been calling myself that for many years. So anyway, and I'm also on Drupal at Bix Gomez, so if you need to, if you want to write to me, any questions or comments or complaints, you can go to the Drupal page. It's really not, I need to update it. It's kind of old. So a little more about me. I'm originally from the great Garden State of New Jersey, pictured here. Actually from Woodbridge, which is right there. Okay, so that's there. Which is exit 12 on the Turnpike or exit 131 on the Parkway, neither of which are pictured here. Since the 90s, I've lived just up the road in Seattle, which is a place that we've called home for a long time. We went back east for 4 years, but you can't go home again once you've lived out here, I guess. So we came back in 2001, and we've been living up there ever since. I love the Beatles. That's kind of an important thing to know about me. I always have. I think I could probably thank my older sister for that. She's 15 years my senior, and it's all she played in the house for like the first 4 years of my life, and it stuck. I also love silent film, especially the German expressionists, some of whom are pictured here, expressing themselves. This is from Nosferatu, and actually, Nosferatu features Max Schreck as the vampire, and this woman here is actually Mrs. Schreck. It's a little trivia, a little silent film trivia for you. That's actually the woman who was married to Max Schreck. And I also love trains, especially old English trains. I just can't get enough of old trains. I sometimes do photography. You can check out some of my stuff at this site, which is junkdrawerphotos.com. It's pictures of people's junk drawers. It's pretty self-explanatory. I've been meaning to start that project back up. And also I have a band. We're called Mysterious Face, and you can check us out at mysteriousface.com. And now we're back in New Jersey. Okay, so let's get going with what I'm here to talk about, which is the wonder and beauty of the viewport unit. So first, some technical info and definitions. Everything I'm doing today is happening on my website, on bixgomez.com. This is a local version, but this entire thing is on bixgomez.com. There's no slides per se, just the examples I put together for this session. The pages themselves are all accessible from the drop-down, and I put as much code and descriptive text on them as I could, and I probably won't even, I'll probably open a text editor once or twice during this thing, but everything else is on the site. It's a Drupal 8 site. It's bare bones, custom theme. It's based on stable, and there's really nothing to it. Actually, all the concepts I'm going to talk about are applicable anywhere, not strictly Drupal. And of course, I'm using Sass and Breakpoint Sass for my media queries, and I've got Gulp running over here for my live reload. Maybe make sure that live reload is actually on. Yeah. Okay. So what are these things? Here they are. They're just units of measurement, and you can use them wherever you'd use pixels or ems or rems or percents to set dimensions on elements. So, for example, you can say things like font size 1.2 VH, height 30 VW, padding left 5 Vmax, and stuff like that. So wherever you could use pixels, you could also use viewport units. So first up, first and foremost, we have VW, which stands for viewport width, and it becomes really weird to say VW all the time because of the car, but that's what it is. And where one VW is 1/100th or 1% of the width of the viewport, which generally speaking is the browser window. This is the one we'll be using the most. I tend to favor it. I find it the most useful to solve the kinds of problems that I personally encounter. Then we have VH, or viewport height, where one VH is 1/100th or 1% of the height of the viewport. This is my second favorite unit, although I don't use it nearly as much as I use the viewport width. Then we have Vmax and Vmin. Viewport maximum is 1% of the height or the width, whichever happens to be largest at any given time. I hardly ever use this one. It has its place, but I have yet to really encounter a use case for it. I can see where it's useful, I just haven't done it. And also, it's the only one that apparently doesn't have, it's got a little bit of a browser compatibility issue. IE11, for what it's worth, doesn't recognize it. So, if you really want to be a stickler, you can just avoid it. And finally, Vmin, which is viewport minimum, which, like Vmax, it's 1/100th of the viewport height or width, whichever is smaller, whereas Vmax is whichever is larger. So what's so great about them? Well, the beauty of these things is that they're the only unit of measurement that changes the pixel value of an object dynamically as the viewport changes shape. So it's something that in the past we were only able to achieve by running like a bunch of JavaScript functions on a resize element, resize event, which can be kind of a pain and not always terribly performant. You can use them in conjunction with ems, which are relative units. So you can set like a master font size on a wrapper element using a viewport unit, and then you can set like your child sizes using ems. That way it's easy to set size ratios using ems, and then you can just change a single viewport unit to adjust the overall sizing. And I'll demonstrate that later. And of course you can use them anywhere: margins, padding, heights, widths, font size, and even absolute positioning if you find the need to do that. So what's not to love? Well, the main pain point is that you can't use the browser's native resize function. If you've set the size of something using, like, say 50 VH, it'll always be 50% of the viewport height, no matter what. So it kind of renders command plus and minus useless for some things. It's kind of a weird feeling when you're trying to zoom in on something and it won't change because it's the viewport unit. It's not it's not responding to it. The other thing is that it doesn't work really well on CodePen. So if you like to use CodePen to fool around with things, because the sidebars and some of the stuff on CodePen kind of take up space in a way that gets in the way. It can also be a little frustrating to work with if you're like constantly referring to your inspector. So if you're opening your inspector up a lot and closing it, sometimes it'll get in the way because it changes the viewport height. But that's a minor complaint. Okay, so let's move on to some examples. So first, here's some basic comparisons between pixels, percents, VHs, and VWs. This first box here is 300 pixels wide. It's always going to be this one. It's wavy up there. It's always going to be this wide, so that's kind of our control group. The second one here is 50% wide, which means it's half the width of the containing element, not of the browser or the viewport itself. And then this one is 50 VWs, meaning it's half the width of the viewport itself. So if we shrink the browser down horizontally, it shrinks and expands according to the viewport. And then this one is 50 VH wide, so it corresponds to the height of the viewport in the same way that VW corresponds to the width. So anyway, yeah, so that's that. And so here's some really basic examples of each of them. In this example, we have a box that measures 30 VH square. So the box will always measure 30% of the height of the viewport. So as we resize the browser up and down, the box's size adjusts accordingly. I also made it so the text will resize according as well, so that it'll always fit inside the box. So that's one thing you can do. But check it out. If I plus and minus it, that box doesn't change because it's kind of stuck in its own viewport universe. So next one, we have a box that is 20 VW square. So the box is always going to measure 20% of the width of the viewport. And so you resize the browser horizontally, and it adjusts accordingly. And we're doing the same thing with the font as we did in the previous one. And next we have kind of the meeting of the minds, so to speak. This box is 40 VHs tall and 40 VWs wide. So the box is always going to measure 40% of the height and 40% of the width of the viewport. And in addition to this, I'm also having a little fun with the fonts. I set the line height at 11 VH. Can you view the code okay? Okay. Yeah, we could do this. Yeah. So it's kind of useless, but it's kind of cool that you can change just an example of how everything can be changed using viewports. So now, so here's the mysterious and strange Vmax. This box is 30 Vmax square, so it's always going to be 30% of either the height or the width, whichever is greater. So right now the width, you see, is greater, so it's 30% of the width. But once we get down to the small end, where the height is actually greater, then it's going to correspond to the height until you get down to the point where the width is the max. So that was the hardest one for me to wrap my head around when I first started learning about these things. And like I said earlier, I haven't found really a use case for it, but I'm starting to think of things that where it might be useful to keep things constrained in a window if you really needed to do that for some reason. And then this last one is vmin. This is a 30 vmin box. So it's always going to be 30% of whichever is less. So in this case, the height is less, so it's 30% of the height. And then once you get down here, the width is what's left, so less. So it'll be 30% of the width. So they're weird. Okay, so I think it's time at 13 minutes past the hour to look at some practical use cases. I hope I'm soothing to the baby. Am I soothing? Okay. I'm trying to be soothing. It helps. It helps keep me balanced. Okay, so this one's kind of cool. It's useful in some cases, but just under certain conditions. But it's a good one to start with because I think it's a good example. So this is when you want your footer to appear at the bottom of the page, but your content isn't tall enough to push it down far enough. I think we've all been there. And we don't always want to use absolute positioning for this stuff. So this one I'm going to open up the code for. Here's the Sass. And here's the template file. It's a simple layout. The header isn't even in here because the header's in the wrapper overall page template, so it's not even in this template. But you get the idea. It's like there's main content, and then the footer, and there's also a header. So, yeah. So this, let's see, is this the right one? Uh-oh, I got to comment this out. I always forget to comment this stuff out, and then it gives away the magic. Every time I did this presentation, I neglected to comment these things out. Okay. Okay, there we go. All right. So, so this really only works if you set both the header and the footer at specific heights, which is why it's not always terribly useful, but we'll do it anyway. So let's start by setting variables for the height of the header and the footer, and these will be our known values. So we've got 100% height or 100 pixels for the header height, and 125 for the footer. So I'm going to uncomment these, and I'm going to set, I'm going to hide the overflow just in case. And so now the header and the footer are at known values. Next thing is that the overall page wrapper needs to be at least 100 VH, so it needs to be at least the height of the viewport. So I'm setting a min height of 100 VH, which you can't tell here because because it's always going to be the height of the viewport. But if I changed it to like 200, if I change it to 200, then you can tell that the container is 200% of the viewport. But I'm going to put it back at 100 because that's what we need. So now here's the fun part. So we have to make sure that this middle part takes up at least the rest of the space between the header and the footer. So we need to make this space large enough at minimum so that the footer is pushed down to the bottom. So we're going to use a calc function because we need to add two pixel dimensions together, and then we need to subtract them from a VH dimension. And the calc function was designed to do exactly that. It's to mix size units. So here we go. So we'll set the min height of the middle div to a value equal to 100 VH minus the combined values of the header height and the footer height. And you'll see also that we're using a hash and braces. This is because we need to interpolate these values in order to use them in the calc function. Calc is a CSS function. It's not a Sass function. So calc doesn't understand that these are variables. It just interprets them as strings if we don't interpolate them. So we have to interpolate them on the Sass side so that CSS can then run the calculation at runtime. So now I'm going to squeeze this down, and I'm going to save it. And lo and behold, the footer is stuck to the bottom where it belongs. And if there's any more text, if there's more text in this content area, it'll still be, it'll allow it to naturally push the footer down, so we don't need to worry about that. So, yeah, so that was okay. It's nothing I think to write home about, but I think it was, a decent example of how to start thinking about these things. Well, the next one I think is going to be more fun and in some ways a little more practical. So this is the case of the full screen header. In this scenario, we've decided we want our header to really hit you in the face when you're looking at the site on your phone and maybe also on your tablet. We want a full browser experience. So we're going to use some breakpoints, and we're going to take a mobile-first approach. So I'm going to open up I'll open up the twig. It's kind of stupid because it's, that's it. It's a content area and a header, so we don't really need to look at that. I'll open up the Sass. Oh gosh, it ran. I hate it when the sausages. I shouldn't make sausage reference. I'm vegan. Anyway. So the first thing I'm going to do is uncomment the first setting here. I'll shrink the browser down, and I'll uncomment the first setting, which is setting the header height at a full 100 VH. This picture was taken at Richmond Beach in Seattle. For those of you who haven't been to Richmond Beach in the summer, it's just wonderful. And they put in a new pedestrian bridge over the railroad, which I enjoy. So pretty cool. So no matter what you do, the header element is 100% of the viewport height. and everything else occurs beyond that point. But we don't want it to be like this for desktops, I don't think, or maybe we do, but let's pretend that we don't. And maybe not even for tablets. So I'm going to uncomment a couple other things here. So we'll make it 50 VH at around 700. And then, after about 900, let's say we'll want it to just be normal again. So it gives people kind of a different experience depending on what they what you want them to see. And I'm going to uncomment these things again, or comment them. So the next time I do this, I hope it was the baby. I'm sure it was me. Okay, so here's a use case that I think Mike is going to recognize in theory. But it's a use case that actually just recently came up in a project I was working on, and it kind of feels very real world to me at the moment because it's actually out there and in use. This is what I call the case of the carousel plus teasers problem. So what we have here is a featured content area, this whole content area up here in kind of the light mauve, that has either an image or you might imagine a carousel to the left, and then it's got 3 teasers on the right. So we can imagine the teasers each have a title, maybe they have a thumbnail image or an icon, and just enough text to fit on 4 lines. The carousel, let's say it's a set ratio, that it's not designed to change its relative height and width, so that's something we need to work with. Since this is a simple grid, we're just using Flexbox to lay it out. So we've got a simple 1-to-1 ratio between the left and the right. So let me open my inspector. And I'm going to set this to responsive at 75 because I think that's the best way to show what's happening here. So somewhere between 1,300 and 1,400 pixels, this particular example looks fine. The image or the carousel or whatever isn't too tall and it isn't too short, and neither is the teaser block. But when we get narrower, or we get, the teasers get really big relative to the carousel, and it leaves us with an ugly white space under our image. And if we go wider, you get the same thing happens on the other side. So that's the problem we're trying to solve. And this is where I say VWs to the rescue. Just not those fake diesel VWs. Okay, so in this example, we can easily start to fix this by just changing all the measurements to VWs. So here's my SAS. So I came up with 47.5 VWs for the image just by hunting around for what looked the best, and 40.5 for the posts. And I also left a margin of 1.6 to the left of the posts so that there's a little padding. Let me see. I'll show something else here. Inspect the title element. So because inside each post, the font sizes and the margins are all set using M's. See? Big enough? All we have to do is simply apply one VW unit to the parent div, and then everything inside will follow suit. Even if the teasers had thumbnails, as long as we're using M's in there and not rems or pixels or percents, we're going to be good to go just by setting the font size value of the container using a VW. So now, let me do this responsively here. We can go as wide as we want, and we can go as narrow as we want, and we'll never end up with that ugly white space. But you might be saying to yourself, this is kind of unrealistic and kind of silly because the text is like really tiny at the small end, and then also the layout just keeps getting bigger and bigger. You know, most sites have some maximum width. I tend to be a big fan of the 1200 pixel maximum width. But this one just keeps going. We're at 1600 and keeps going. So let's try to solve that problem as well. Oops. Responsive view is always weird. It thinks it's trying to be a phone. Okay, so this is the mobile fix with trouble at max. So in this version, I need a little more water. So on the mobile end, we're just fixing this by taking a mobile-first approach. So, you know, we're just not doing this font stretchy thing until we get to a breakpoint where the text starts, you know, becoming legible. And I guess I'm doing this around the medium breakpoint, which is 800 pixels. So you don't have to worry about the teeny weeny text. But check out this other difference. See how we've moved the VW units up a level. So at the medium breakpoint, we're now assigning a font size value of 1 VW to the featured div itself, so the wrapper, which is where both the carousel and the posts regions reside. This means everything inside this div, the widths, the margins, the padding, and the font sizes will all follow suit as long as we express them in ems. We're still using Flexbox, but only because we still need each column to be like the height of the tallest one. So Flexbox is good for that, and I just use it. But now we're using specific widths for each column. We set the flex as none, so it doesn't, you know, care whether it's 1-to-1 or 2-to-1 or whatever. And so the carousel is now set at a width of 47M, which, like before, I just found by hunting and pecking. And the posts is set to 36M, and the post font size is 1.15M. And at that point, it just kind of works. But, sorry, startle the baby. So what happens when we get beyond, we try to constrain this to a maximum width, which in this case I constrained the whole page wrapper to 1200. But when we exceed that maximum width, it's kind of a mess. The fonts and the steering wheel, they just keep getting bigger and bigger forever, and it gets ridiculous. So now we really need to curb our enthusiasm. And the solution to that is actually surprisingly simple. I think it's surprisingly simple. Remember how we rearranged things so that the featured region is the only div that we're assigning a viewport unit to? Well, that means that we can easily stop it from growing at a certain point. Because I chose 1 VW as the default font size value, we can figure out that at the max, let's see how I can say this right. At the max site width breakpoint, the font size will be the equivalent of simply the max site width divided by 100. See? So that way, we responsivize it again. It works. So everything at 1200 and above, at 1200, everything just stops growing. So this is what I mean by not having too much fun. We're really just using the VWs to deal with a relatively small range, this range right in here, where things would otherwise look weird and you get ugly white space. So there you go. Okay. So now it's going to get a little even crazier. This is my last big example. And this is probably, for me, the most practical use case for viewport units, which is growing and shrinking text to improve legibility across a variety of different size devices. At this point, it's going to get a little weird for me because I'm pretty much saying what's right here on the page. So you can kind of, in some ways, you can read along. But I thought it would be more useful than a lorem ipsum, especially if anyone were to visit the site and wanted to, kind of read it and see what I was doing. But here goes. So as we've seen in previous examples, as it says here, the most straightforward typographical gesture we can make is to assign a VH or VW value to a block of text or to its containing element or even to the HTML element itself. So in this example, we're setting the global font size of the HTML element to 2VW, which is 2% of the viewport width, and we've got the body font size set at 1em in order to maintain that value as a default. So this gives us, I guess no surprise, correspondingly larger text the wider the browser gets, and it also gives us increasingly illegible text as the browser gets smaller. So, it's pretty extreme, and I think it ends up causing more trouble than it solves. We end up with text that's either too small for a phone or way too big for like a big monitor, and just like just a small little Goldilocks area in between where it's just right. A more reasonable solution, I think, would be to use what I call gentle text enlargement. This, I think, is a more gradual effect that starts small for mobile, but not too small, and it gets larger with increasing browser width. So in this example, we start with a reasonably legible mobile font size of 12 pix, and then we increase that by 3/4 of a VW as we grow horizontally. So like before, this gives us larger text as the browser gets wider, but since we're only adding 3/4 of a VW to a baseline font size, by the time we get to the size of a large monitor, the text isn't humongous. It's still pretty big, but it's not ridiculous. At least now we know we can regulate it, is the idea. So now I was thinking, if we can add VW to a base font size, what would happen if we subtracted it instead? Well, I guess you can imagine. In this example, we start kind of arbitrarily with a pretty large font size of 24 pix, and then we subtract 0.6 VW from it. And so now the text is smaller on the wide end, and it gets larger at the narrow end, which actually, come to think of it, isn't entirely without merit. We might want a slightly larger overall font size for a smaller device. I know I often do because my increasingly myopic vision has me looking for that easy reading button more often than I'd like to admit. But we still probably want larger text size for larger windows as well. We don't really want it to end up getting smaller and smaller and smaller till it winks out of sight on the large end. That's kind of not ideal either. So this brings me to the concept of the two-way enlarger. With this one, we start with the 24 pixels, and then we subtract 1.25 VW from it. So it's getting bigger at the small end, and it starts getting smaller as we get bigger. And then at a specific breakpoint, we switch from, let's see, this is where we switch. We switch from that to a base font size of 7 pixels, and then we start adding 1.25 VW to that. So at phone resolutions, the font size increases as the viewport decreases, like before, but then somewhere in the tablet realm, it starts to shift, and the font size starts increasing as the viewport gets wider. But, it's kind of a pain because it's kind of difficult to be hunting and pecking for the right combination of font sizes and VW values. It's not impossible, but it's just a little tedious. But through the miracle and beauty of SAS functions, it doesn't have to be that way. So this is the climax. The climax is coming. This is the climax. So this experiment solves that arbitrary hunting and pecking problem. Like I said, we're going to use SAS functions and some simple math to figure out what combination of settings would give us the font size we want at the breakpoint of our choosing, where we'd like it to switch, where we'd like that switch to occur between increasing upward and decreasing downward. So let's say we want the base size to be 12 pixels, and then we want the text size, we want the text to be that size at the 800 pixel breakpoint, which is it's expressed on this site as a medium. That's the breakpoint variable that I set at 800 pixels. So let's also say that we want the font size to increase at a rate of 1.75 on the way up, greater than 800 pixels, and we want it to increase at a rate of 1 VW on the way down towards mobile. It's arbitrary. It's what I decided looked the best for this. So that in the SAS, it looks like this. We set all of our variables. We set what I'm calling the threshold pix at 12 pixels. We're setting a switch point, so I call it a switch point, at the medium breakpoint. We have a VW rate up of 1.75, and we have a VW rate down at 1.0 VW. The values we don't have and what we need to figure out are the base font sizes, the font sizes we need to start with in order for the resulting font size to be 12 pixels at that breakpoint. It's not going to be 12 pixels because we're either adding 1.75 to it or subtracting 1 VW from it, depending on which side of 800 pixels we happen to be at. I'm calling these the upsize and the downsize. And I'm sending all of these known values into a SAS function, plus an extra argument here, add or subtract, telling the function whether we're going to be adding or subtracting that value. And this is going to do the heavy lifting and come up with the two magic numbers. And then we'll then apply those magic numbers to, we assign them as font size values before and after the breakpoint. I want to keep you in suspense. So here's the SAS function. SAS functions, they're written in, they're simple SCSS files, and they can be placed anywhere. I tend to stick them in my own functions directory, and I call them pretty early in the SAS chain, usually right after I declare my variables. So this function receives the four values we're sending it. Threshold pix, the switch point, the VW rate, and what I'm calling the operation. So the first thing it does is it strips the units from the first three arguments using a function I found at csstricks.com called stripUnit, which does just that. It strips pix, VW, etc. off, and it returns. Oh, good. They finished before me, so I'm not rushing, because I'm almost done. And then we divide, and it returns just a purely numerical value. So the font size just returns the font size minus the pix, and the breakpoint would minus the pix, and the viewport factor minus the VWs. So then we make a simple calculation. We just multiply the breakpoint by the viewport factor, and then we divide that value by 100. So in the first case, what it does is it multiplies 800 by 1.75 to give us, and then divides that by 100, and that gives us 14, which is 1.75 VW's value in pixels when the viewport is at 800 wide. And then finally, we either add or subtract this value from the desired value in pixels, which I guess is, it's font size, depending on whether we're going up or down. So this is if we're adding it or subtracting it, so the add and the excuse me, and the subtract. And that magically gives us the value, which we then add or subtract from our VW value back in the original SAS file. So this gives us a nice, smooth transition, see, at the threshold breakpoint. And I could do this all day. I could just do this all day. I just think it's so cool. And actually, I think it's a little small at this point, maybe. But yeah, it is a little small at that point. But I thought it would be maybe a more extreme example would be a little more fun to watch. We could very easily change this value if we changed threshold picks to 16 or 14 or 24 or whatever, and we changed we could change all these, and it would still give us the same nice smooth transition, and we don't have to do all that hunting and pecking around for the perfect combination of pixels and VWs. And that's what I think is so cool about viewport units. And that's all I have for you for now. So yeah, thanks. Questions?
How long did it take you to figure that last bit out?
25 minutes. I don't know. Yeah, I mean, it's like, I'm not a math person, so, but I kind of didn't really discover, having actual fun with math till I started, working in SAS. And so, it was probably percolating for a couple days, and then I figured it out.
So
Yeah.
How universal is SAS? I mean, it's a browser issue.
Well, SAS is something that happens in development. So SAS is never something that runs on a server that you're serving the site. So what happens is you write in SAS, and then you have something that compiles your SAS and writes CSS.
Oh, okay.
So you're still just delivering CSS,
Right.
but while you're writing code, if you're writing it in SAS, it's like constantly compiling it and making it into CSS. Which actually, there's some new evidence out there that sometimes if you're not structuring your SAS in a smart way, you end up with really ugly CSS.
So, so let's say I'm using like CSS injector, so I do something on a local machine with SAS, and then get the CSS out and put that in.
Yeah.
Yeah. Okay.
Yeah.
Cool.
Yeah. That's it. Yes.
Yeah, so I kind of played with this stuff a couple weeks ago. I was using CodePen, and some of the first boxes that you show that kind of scale in various ways, I was learning about how, or I was just kind of experimenting with it myself and watching stuff scale off the screen and things like that. What I'm thinking is like a real challenge in the community is educating the designers on what is capable in responsive design. Because a lot of the times, I end up working for mockups that are like, here's the desktop version, here's the mobile version.
Right.
Well, I'm working on a large format, widescreen, high-res display, and I don't know what you want your site to look like here.
Yeah. Yeah. Or you're using something like Zeppelin or one of these other things that you can't really do that stuff with. And yeah, it's a good point. Informing designers of what's possible so that they can. But I guess that's where we as themers should be working with designers to help them understand, and it's like a communication thing.
Yeah.
But sometimes that's not going to happen because the designer. I mean, we have a designer now who's very web savvy. She just knows what can be done, and if she doesn't, she'll ask us. She'll say, hey, she'll ask one of the front enders, is this possible? How would you do this? I'm thinking I'll use JavaScript for this or that, and we'll say, yeah, but you could also do this, and so it's a give and take communication
really
thing.
Like a collection of just really cool samples that like you couldn't do without this stuff.
Right.
Like educate them, and then also have implementation for front end people.
Yes, excellent. Let's do that.
With all our free time.
Yeah. Yeah.
Since you used calc at the end to output then a font size, does that solve the zooming problem? Or can you still not zoom on this?
No, you still can't zoom on it.
Okay.
It's still it's so stupid. Oh wait, it zoomed. Well, because that's it did zoom after.
I think you're scripting the units, passing it back in as a pixel, and then calc doesn't care, and it's just outputting as.
Yeah, but here, but at the small end, it's not. It's still staying the same.
It's definitely not scaling with the same
Is it
range.
scaling
as
a
the
different
menu.
way?
Well, it's
Header's getting tiny, your text is getting big.
right. Well, my header, that's not part of the VH. That's just set using pixels. But this part is. But then I forget. I don't know what happens at this point at 200. Why it's now. Oh, you know why? Because it thinks. Oh wait, does it think the viewport is small? That's really confusing. That's weird. Why does it start changing after a while? Well, suffice it to say, it's weird.
Like when you zoom, I think like the pixel width gets recalculated. So like when you zoom in,
It should.
It's saying that your pixel less or something.
It should, but it doesn't do it. It doesn't start doing it until like 200%.
It might be your like two-way code that you have there. Where it's like
Maybe. Yeah.
Okay, so
Yeah. Maybe. Yeah. You're right. Yeah. Because it's saying that the viewport is that size. So if we went to the first one, the simple one that just doesn't, that probably, yeah, that it won't do it. So even like the virtual viewport width isn't changing.
This actually made me think like also there's like best practices for like readability in print and like basic responsive design. I feel like a lot of those are going to have to be reevaluated now that we can scale text like this.
Right. And like different phones will be different sizes, but like where does it end? Like how big is this font on this phone
So you're kind
at
of
this
using
distance?
research at this point where people like actually do studies and determine like
Well, or just let people scale up to what they want it to. I mean, that's the
Right, and that's where like we've
didn't have your glasses on, right? Like,
right.
but that's not
can't
going
read
to
it,
work on
so-
like tablet or your phone where
Picture
it's
zoom,
more
we'll scale.
Right, so we've just ruined it for that. So I wonder if what we're doing is actually not accessible at all because you
What you
can't.
need is a function based on the pixels of the viewport, right? So,
Yeah.
so as you get higher resolution, you get more pixels in a viewport space,
Right.
right? And your text gets smaller. Yeah. Have you ever had to single boot a Macintosh on a new 5K display?
No.
It doesn't handle that at all.
Oh really?
Yeah, you need a magnifying glass to.
Sounds like when you try to run Linux on a Mac and it doesn't recognize your Retina and everything is teeny.
Yeah. Yeah, but I mean, it's the same kind of, and that's,
Yeah.
all these different phone devices, they keep increasing that resolution, but then,
Well, that's what keeps us employed.
yeah.
well,
If everything were as simple now as they were in 2001, we'd still be using tables.
it's kind of awkward because like I want to take the time to like make things look awesome at different resolutions, but at the same time, if I just had something I could like copy and paste for best practices and move on, that would also make me happy.
Yeah, true. But then it wouldn't be as fun.
I'm a back end
That's
dev.
the not.
Well, I want to keep having fun. Anyway, so cool. Thanks for coming. Thanks for sitting here and listening to me. I wish the baby were still in here. We'll see more of the baby. The baby was really helpful.
You have like five breaks. Close.
Thank you. Good talk.
Hey, thanks. So I didn't know about Mike until this morning.
Oh wow.
Yeah, because I didn't really know him. I didn't know. I mean, but I knew that I always saw him at these things.
Yeah.
And like I subconsciously look forward to seeing him
Yeah.
because he was just like the guy in the crowd who would come to me and ask me how I was doing and have a little conversation. He's just like he was there. In fact, when I got here this morning, I realized when I got here that I thought I saw him.
Yeah.
And I was like, oh, that's that. Oh, no.
Yeah.
You know?
That even happened to me too. Like seeing someone like leave the room and like they kind of have a similar haircut or something.
Yeah. And you knew you could just go up to him and start a conversation, and it would be, there's no judgment. Not that that any of us are that way,
Yeah.
but he was just so warm and.
Yeah, it was such
I
a
wish I'd known
shock
him
too
better.
because it was like, over the holiday, it's like maybe you guys need to hear this, but like over the holiday, emails went out and. He was working with Fuse IQ, and so Jeannie sent something out to